Hello again. So let's zoom in so you can see clearly. I think that's enough, and then I can go down a little bit. We are now in problem 41. In problem 940, you found that the points on the line are the only points that make the equation y is equal to negative 2x plus 3 true. But what if you want the graph of the solution for the inequality y is greater than or equal to negative 2x plus 3? How will the graph differ from the graph of y is equal to negative 2x plus 3? Consider these questions as you follow the steps below. First, you will be given a list of points to test in the inequality. For each of the points that makes the inequality true, place a sticky note or a sticky dot on the point on the class graph. I'll be just showing you the graph. Again, we already graphed this originally. Okay, so our graph originally was this. Okay, I will just draw the graph in here. So we'll just make x and y axis. Okay, and sort of show how it is done. Okay, and then let us okay, now we will make sure that we will point our 3 again. So we'll have 1, 2, 3. So we went down 1, 2, and 1 here, and we made a connection. That's our line. Okay, so that's our graph for y is equal to negative 2x plus 3. Now, we are to find some points if the points will make the statement true. Let's start with 0, 0. This is my 0, 0. Okay, let's say test 0, 0. Okay. Okay, so for 0, 0, let's substitute our 0, 0 to our equation here. So y is greater than or equal to negative 2x plus 3. So we will substitute 0. This will be 0, and this will also be 0. So as you can see, if I can cancel this, because negative 2 times 0 is 0, is 0 greater than or equal to 3? Is it true or false? We know that this is false. Okay. So 0, 0 is false. Let's test another point. Let's say, let me get a point somewhere here, 1, and let's say another point, that's negative 1, negative 2. I have a point here, negative 2, 0. Okay, so let's test negative 2, 0. It's easier to test with zeros actually. So this is your x, this is your y. So your y is 0, is greater than or equal to negative 2 times negative 2 plus 3. 0 is greater than or equal to, this is 4, plus 3 is 0 greater than or equal to 7. Again, that is false. Okay, let's try without 0. Maybe we'll get somewhere. So 1, 2, 3. So this point, this is negative 2, 3. Let's try negative 2, 3. So your y is equal to 3. Okay, it's greater than or equal to negative 2 times your x is negative 2, and then plus 3. So 3 is greater than or equal to, this is 4 plus 3. Is 3 greater than or equal to 7? Again, this is false. Okay, let's try to get on the other side, this side. Let's say 1, 2, 3. This is 3, 0. Let's try 3, 0. 3, 0. Okay, so your x is 0, greater than or equal to negative 2 times 3 plus 3. 0 is greater than or equal to, this is negative 6 plus 3. 0 is greater than or equal to, this is negative 3 plus 3 is negative 3. Is 0 greater than or equal to negative 3? This time it is true, because we know that negative 3 is less than 0. So that's true. Let's try another one. This is 3, 4, 5, let's say 6, 0. So let's try this, 6, 0. Okay, so this is your y is greater than or equal to negative 2 times 6 plus 3. 0 is greater than or equal to, this is negative 12 plus 3. 0 is greater than or equal to negative 9. Again, 0 is greater than negative 9. So as you can see, every time I will get a point on this side, on the right side of your line, or above, if you may, this is below, this is above, or the right side, left side, whichever way you call it, your point is always true. Okay, let me 2, 3. Let's take the last point. Let's have 2, 3. Last point, 2, 3. So this is your 3 is greater than or equal to negative 2 times 2 plus 3. Is 3 greater than or equal to, this is negative 4 plus 3. Is 3 greater than or equal to negative 1? Again, that is true. Okay. Now, examine the solutions shown on the graph with your team. Discuss the questions below. Okay. For letter or first question, are there any points on the graph that you suspect are solutions but do not have a sticker? Okay, let's have these points. These are, the ones here are not a solution. The ones here are solutions. So the solution, we will mark it red. Okay, those are solution. So we can answer this point. Any point on the right side is a solution. Or we can say points on the right side or above the line is a solution. Okay. Let's have the second question. Are there any stickers that you think may be misplaced? If so, verify this point so that you can have a complete graph or solution. So we can say that by substituting the value of the points, we can verify if it's on the right side or on the left side. So by substituting substituting the coordinates of points, we can verify if it's a solution. What about the points on the line? Okay, in our previous example, the points on the line, remember the points here, that is our 2, -1, it's a true solution. And another point here, it's actually, that's -1, 5 is a solution. If I were to flip our paper, okay, our -1, 5 is true, and our 2, -1 is true. Okay, so therefore, we can say, we can answer this part, the points on the line are also a solution, okay, to the inequality. So because there's an equal sign here, we can say the points on the line are also solution to the inequality. Okay. Next question. How many solutions do you think are there? So if we are to check these points, are these the only points on the right side? We say no. So there will be infinitely many solutions or infinitely many points. Okay, so we say infinitely many solutions. And then for the last one, where are all the solutions located relative to the line? We can say all the solution points are on the line or on the same side of the line. All the solution, all the solutions points, solution points are on the line or on the on the line or on the same side of the line, and that is on the right side, okay, on the right side of this line. Okay, so why are there no solution on the other side of the line? So this side is not a solution. So this side of the line on the left side is not a solution because they do not express a true expression or does not satisfy the inequality. So we say that the points that does not satisfy the inequality. When you say satisfy, it does not make the statement true or it makes the statement false. Does not satisfy the inequality are not solution. Okay? Or you say the statement are false. Because when we check, these statements are false because they are not part of the solution. So this is the answer for the last part. Okay. I'll continue with the next number on the next video.